Hey, welcome back to ClearSpot. Here's a number that should terrify every solar operator. 67% of operators face major data quality issues. And those issues aren't just inconvenient, they're expensive. 208 to 312 hours per year of data is missing. 90% of alerts are noise, false positives from bad data. Sensor drift causes 8 to 15% cumulative error after just 3 years. The financial impact? $620,000, $780,000 lost per 100 MWh annually. Over 5 years, that's 3.9 million in preventable losses. And here's the worst part. If you're investing in AI for predictive maintenance, anomaly detection, or performance optimization, bad data makes your AI worthless. AI accuracy collapses. Field teams stop trusting it. Your ROI disappears. This is the data quality crisis nobody talks about. Today, I'm showing you exactly what goes wrong with solar monitoring data, why it happens, and the validation strategies that separate high-performing operations from the rest. Let's fix your data foundation. Data quality problems in solar monitoring fall into 5 categories. Missing data is the most common issue. It occurs when sensors malfunction, communication errors disrupt data transmission, network outages prevent data logging, SCADA system failures stop recording. The scale of the problem: average solar farm, 208, 312 hours year of missing data. A single 6-hour outage during a heat wave can reduce AI accuracy by 40%. Data gaps get amplified during temporal aggregation, daily, monthly averages. Why it matters: missing data equal missing failure signatures. Your AI literally cannot learn from events it never sees. If a failure occurs during a data gap, you have no record of what happened or why. Outliers are unrealistic data points that don't match physical reality. Negative irradiance values. Impossible. Power output exceeding system capacity. Physically impossible. Temperature readings jumping 50 degrees in 1 minute. Implausible. Sudden voltage spikes outside equipment operating range. Types of outliers. Point anomalies. Single measurement deviates from expected value. Contextual anomalies. Value is normal in isolation but wrong given context, e.g. high production at midnight. Impact. Undetected outliers skew performance metrics. A single spike can throw off daily averages, PR calculations, and trend analysis. All sensors gradually lose accuracy over time. Pyranometers, up to 1.5% drift per year, Class B. Temperature sensors. Drift varies by type and environment. After 3 years without recalibration, 15% cumulative drift. Why it's dangerous. Drift is systematic. It biases all your data in one direction. Your PR looks consistently 5% better or worse than reality. Your AI models become systematically wrong, not randomly wrong. Data corruption during transmission creates duplicate records, same timestamp, same value logged twice. Corrupted values, garbled data from transmission errors. Timestamp, misalignment. Data arrives with wrong time. Protocol conversion errors. Modbus. Database translation issues. Impact. Corrupted data flows into analytics pipelines and AI models, producing systematically wrong outputs. Different data sources have different time resolutions. Inverters logging every 5 minutes. Weather stations logging every 1 minute. Energy meters logging every 15 minutes. SCADA aggregating at different intervals. The problem? 15-minute intervals miss events lasting 2 to 4 minutes. Cloud transients, inverter trips, and rapid fluctuations are invisible at low resolution. AI needs 1 to 5 minute data for accurate anomaly detection. 15-minute data is insufficient. Let me show you exactly how data quality impacts AI performance. The AI accuracy cascade. 43% of operators have no validation layer. Corrupted data flows directly into AI. 15-minute resolution versus 1 to 5 minute. Miss 40 to 60% of short duration events. 5% sensor drift. AI predictions wrong by 5 to 8%. Single 6-hour data gap, up to farce accuracy reduction for that period. Uncalibrated sensors. Systematic bias in all predictions. Your pyranometer drifts 1.5% per year. Class B sensor. After 3 years without recalibration, it's reading 4.5% low. Your AI thinks irradiance is 950 when it's actually 1,000 balasar minadu. Your AI calculates expected production based on 950 billion. Actual production matches $1,000 conditions. Your AI now thinks your farm is overperforming by 5%. Like, share, and subscribe for more solar insights. ClearSpot. Smart device, smarter decisions.